Hi, in this video I will explain briefly the concept of solubility and the factors that may affect solubility. By definition, solubility is the maximum amount of solute that can be completely dissolved in a certain amount of solvent at a certain temperature. For example, if a certain compound has a solubility of 5 grams per liter of water, this means that the maximum amount of this compound that can be dissolved in 1 liter of water is 5 grams. Any additional amount will not dissolve and it will form a precipitate. Solubility is usually measured in moles per liter, grams per liter, or grams per milliliters. What are the factors that affect solubility? We will mainly focus on two factors, which are the properties of solute and solvent, and by properties I mean the types of intermolecular forces that exist in both the solute and solvent, and the temperature. Properties of solute and solvent. This statement is well known in chemistry, and it says that like dissolves in like. So each compound is going to dissolve in the solvent that has similar types of intermolecular forces. For example, polar compounds will prefer to dissolve in polar solvents, whereas non-polar compounds will prefer to dissolve in non-polar solvents. Why is that? Because a polar compound and a polar solvent will have similar types of intermolecular forces. Similarly, for a non-polar one and a non-polar solvent, again, they will have similar types of intermolecular forces. And whenever two compounds or a solvent and a solute have similar types of intermolecular forces, then they can interact with each other, and this leads to solubility. Example, NaCl, sodium chloride or table salt, which is an ionic compound and is highly polar compound, will dissolve in water, which is a polar solvent, but it will never dissolve in pentane, which is a non-polar organic solvent. On the other hand, wax, which is an organic compound and it is non-polar, will dissolve in pentane, which is non-polar, but it will never dissolve in water, which is a polar solvent. So this explains the idea which I talked about, which is a compound will always dissolve in the solvent that has similar physical properties and similar types of intermolecular forces. Usually polar compounds are said to be hydrophilic, and this means that they have high affinity to interact or dissolve in water, and non-polar compounds are said to be hydrophobic, which means that they hate to interact with water and they have low solubility in water. Solubility of polar organic compounds. Some organic compounds are polar, such as alcohols, amines, acids, and halides. They are polar, but they have a polar side and a non-polar side. Usually, the functional group in the compound represents the polar side of the molecule, or the hydrophilic part of the molecule. The non-polar side is usually the carbon chain, and this is what we call the hydrophobic region of the compound. So usually these compounds will consist of a chain and a functional group. This functional group here represents the polar side of the molecule, and this carbon chain here represents the non-polar side of the molecule. Since these compounds have polar and non-polar regions, they behave in a different way than other ones. The ratio of the non-polar side to the polar one affects the water solubility of this compound. So as this ratio increases, which means that as the number of carbons increases, then the solubility of these compounds in water will decrease. And we usually have a rule which is very common for alcohols and for amines, and it's called the 4.5 rule. What do we mean by that? Starting with methanol and up to propanol, which has 3 carbons, those three compounds are actually completely soluble in water. Now, when we look at butanol, which has 4 carbons, the solubility will decrease and it will be 7.4 grams per 100 milliliters of water. When we add one more carbon, such as in the case of pentanol, the solubility decreases from 7.4 to 2.2 grams per 100 milliliter, and this means that almost pentanol is insoluble in water. Adding more carbons will even reduce more and more and more the solubility of the alcohol. So up to 4 carbons, the compound had acceptable solubility in water. However, adding one more carbon caused a dramatic decrease in the solubility, and this is what we mean by the 4.5 rule. In general, in compounds, increasing the number of, for example, in the case of alcohols, increasing the number of OH groups will increase the solubility of this compound in water, because we are increasing the size of the polar area. Also, reducing the number of carbons in a compound will increase the solubility of a compound. And this also applies for amines and applies also for carboxylic acids. So if we have this functional group, for example, dicarboxylic acid or a diamine, they will be more soluble than compounds which have only one functional group. And again, decreasing the number of carbons will help in increasing the solubility of the compound. The other factor which affects the solubility is temperature. As temperature increases, solubility usually increases. Why is that? Because heating increases the kinetic energy of solute and solvent molecules, and that's why collisions increase, and this helps in breaking the intermolecular forces and promoting solubility. So how does this work? Originally, the solvent molecules will be next to each other because of the intermolecular forces which exist between them. The solute molecules will be outside this shape. However, upon heating, the molecules will start to move at high speed and in different directions. And because of this high kinetic energy, collisions will start to increase. So we will have more collisions between the solvent molecules themselves and the solvent and solute molecules. Collisions usually lead to the formation of heat or energy, and this energy will be used to break the intermolecular forces which are keeping the solvent molecules together. So upon heating, the intermolecular forces between the solvent molecules will start to decrease, and that's why the solute molecules can now get in between, and that's how dissolving occurs. So this is just a simplified picture of the effect of temperature on the solubility, and how does an increase in temperature change or increase the solubility of a certain solute in solvent. So to summarize, increasing the temperature will increase the collision between the solute and solvent molecules, which will produce more energy, and this energy can be used to break the intermolecular forces that are keeping the solvent molecules together and keeping the solute molecules away from them. And by pulling the solvent molecules away from each other, the solute molecules can now get in between, and they will get solvated. So basically they will be surrounded by more and more of the solvent molecules, and this is how solubility and dissolving occurs.